Hello, I'm Dan Peters, the Product Manager for Offshore and Subsea Services at Structural Integrity. Today I want to talk to you about how we are adapting our proven fatigue monitoring software to perform a load monitoring of critical wellhead equipment used in a high pressure, high temperature, commonly known as the HPHT Deepsea market. Deepwater operations are challenging the oil and gas industry to develop equipment capable of handling the harsh conditions associated with the HPHT environments. These applications reside in near-freezing ocean water, more than a mile deep, and the wellhead equipment is exposed to internal sour environments at pressures greater than 15,000 psi and temperatures greater than 350 degrees. Such extremes are beyond the environments currently addressed by API and ASME standards, so they create design technical challenges not previously experienced by undersea equipment. Fatigue cracking has been identified for its increased threat to the structural integrity of these thick-walled components. Fatigue has not traditionally been a concern for deep-sea wellhead equipment. However, the need for thicker materials at HPHT conditions increases the potential for fatigue damage in the form of crack initiation and environmentally enhanced crack growth. Subsequent growth of these small cracks through the corrosion-resistant interior layer and the forging base material could eventually lead to through-wall crack propagation, which could be environmentally disastrous. Lacking the ability to perform in-situ in-service inspections, an alternative maintenance activity is necessary. Structural Integrity's easily applied software methodology for load monitoring of HPHT equipment is called Fatigue Pro. This software has a successful track record and has been applied in numerous applications for more than 30 years in the commercial nuclear power sector and can be readily applied in any HPHT application. In essence, Fatigue Pro provides a fatigue and load odometer for equipment hotspots that serve as leading indicators of potential fatigue initiation. We do this by counting, categorizing, and tracking all of the actual loads experienced by the equipment and comparing them to the loads assumed in the design. The hotspot locations of highest stress are selected for monitoring based on finite element modeling performed as part of the equipment API and ASME code design analysis. Our software is configured to utilize the same methods and inputs that are used to qualify the equipment to the design standards. Then actual loading measured from existing installed instrumentation is used in place of design load assumptions, thus providing in situ measurement and assessment of the actual component duty. So how does Fatigue Pro work? Our software analyzes all measured load fluctuations and compares them to the loads postulated in the equipment design specification. This comparison serves as a first level measurement of the equipment's condition. Fatigue Pro may also be used to calculate a cumulative usage factor to estimate fatigue crack initiation potential or fatigue crack growth to estimate postulated crack propagation. Both of these parameters can be trended real-time to provide insight to operational practices, equipment maintenance, or for proactive planning of equipment replacement. Alert levels can be set to trigger other proactive measures by operators long before equipment integrity is threatened. Field observations typically indicate that actual loads are significantly less severe than the loads postulated in the equipment design. Fatigue Pro's ability to account for these differences can extend equipment life significantly and provide added confidence level in equipment safety and reliability. In addition, evaluation of past or future what-if operational scenarios can be performed to provide important feedback to operators ahead of time that allow for procedure adjustments for planned practices that might otherwise shorten equipment life. Load monitoring with Fatigue Pro provides an alternative way to continuously and cost-effectively monitor the condition of HPHT equipment. Monitoring can be performed remotely onshore at regular intervals, after unusual operational events, or can be integrated into an overall automated surveillance software suite. It can be applied pre or post-feed, as no additional instrumentation on cabling is required. The fundamental principles integrate well-established finite element and fracture mechanics methods to monitor and trend fatigue life tolerance of HPHT equipment during operation. Implementing this methodology also provides key technical data that can be used to improve future equipment designs. Properly understanding the influence and effects of HPHT environments on this new generation of equipment can result in significant design and cost savings of equipment for subsea applications. To learn more about HPHT fatigue load monitoring, you can visit our website or contact me directly. I look forward to speaking with you about your deep sea load monitoring applications.